Good afternoon. I'm Bob King from King & Company. We're a stair manufacturer here in New Hampshire that we've been in business for 35 years. We produce high-end custom stairs with a wide variety. We have been a parametric Staircon user for 4 years now, and we'd like to show you some of the benefits and some of the differences from going to a 3D CAD to a stair-specific parametric 3D software. We will go now from a simple stair scenario, trying to cover our different bases, is a simpler stair underneath, and that is the first floor. There is the second floor. We have help lines. I'm deleting now just so you can see where they are that were in there, that are simple construction lines that allowed you to utilize in drawing and referencing points, getting dimension. Here's a stair that is a little bit unique. It was a very specific situation that I worked a long time to resolve with this customer. But you can see there's the upper level. We can go up to the third floor. There's the balcony balustrade. Everything can be isolated. Elevations. First floor. We can look at just the right skirts. We can look at all the different skirts, balustrades, newels. Then we can go to 3D. Here is a model here that, as I say, there was a simpler stair to a lower level. It was a walkout basement. Here is a unique stair. You can see these transparent slats are actually glass balusters. There'll be a picture after that shows this stair completed and installed. All of these posts are structural, part of the process. There's a post here that was hollowed out in the center in turn so that it actually encapsulates a lolly column. Metal balusters, all of the different components to your specifications, bull nose styles of tread, landing nosing details. All these are easily modified, saved in as a file, which you can easily click on as you go along. For instance, a tread. If you want to change the thickness, you can change the thickness. Profiles. You can change the nose profile. You could do 1/8 inch top and bottom. You can see what it is right there. You can make the changes. Cove moldings. If you want to use gold, you see what the profile is. All of these things are quickly changed. Riser details, you have all the options of how you set it up. The nice thing with this software is that you can set up all of your standards in your database, how you typically want to produce something. Starting steps, you have all the options to adjust and modify everything as you go. Let's go to the next model. Here's the 3D of this stair. If you look at it, every riser is curved serpentine landings. You can integrate a ceiling, show the ceiling in it. Completely modified, the skirt, how you want to transition the bottoms. All that is 100% easily adjusted. Here we have custom balusters that the customer had seen a picture that they wanted, and so those are all in there, readily and easily changed. Custom newels to match. The nice thing for people that are starting to use the 3D parametric software, Staircon will allow you to take a 2D simple AutoCAD drawing and bring this in and create the stair using create from lines and arcs. So it allows us to utilize what we already are real comfortable with in basic CAD, bring that in and create a stair from it, which is a tremendous asset in starting out and learning. It's a terrific feature. As in a typical job like this, we initially did a design based on initial concepts from the customer. She came back with some specific things and said, can I modify the bottom step in this way? We made a modification. She said, that's great. Now can I do a couple more things? And we were very quickly and easily able to modify, send them back out, send them the 3D models back out, never have to meet them face to face, can both be carrying on very easily through the internet, which all we have to do is go into Sketchfab, we send this out. This is what you would send to the customer. You can have your logo up there. You can set your background. You come in. This is what your customer would see. I'm left-clicking my mouse. I can center mouse and panning it. Left-click. I can rotate it around. They can look at it from any angle they want. They can come in and approach the stair. They can come from the top. They can look at it. This is a tremendous selling feature. We can, with this software, be able to introduce doors. We can introduce windows. These are all things that this does the selling for you. When you come in here, you can put a note right here. Clean it without a newel for discussion with them. This is a combination of things that allow this software to really perform. So I think it's in your benefit to consider going to this type of software. The advantages over regular 3D, like I say, is a tremendous asset in being able to send this out, add walls, do all that stuff readily and quickly, be able to shift on the fly with materials, make changes, have everything upgrade because of the parametrics. Other big benefit of what you have when you go to a stair-specific 3D parametric software is you now can, with a couple clicks of the mouse, generate a complete cut list for all your treads, risers, balusters, everything that can go out into the shop. That is a tremendous amount of labor saving. And then if you take it to the next step to go to CAM, which we do, Nate, our CNC person, will show you CAM, what the CAM will do and what it generates.
So this is a project that's already been designed in CAD. I've taken and laid out the stringers exactly how we intend to create them. Here's the right elevation, left elevation. It's got this waterfall. I recalculated my production here, recalculate production data, and I would choose strings, risers, and treads. And then once that processes, I'd go to production, and this shows me all of the strings as they're going to be created. And then we can go through and then here's all the treads and so on and so forth. Once that's done, I will go to create production file, and this will start CAM. So here we've got risers, treads, steps, same thing, and the stringers. So I'll just click process items. It's going to go through and actually process everything, the risers, treads, and stringers, and it's going to create the G-code that's going to go out to my CNC machine. So here are the risers. And this shows all your tool paths. So it does the contour, does a pocket for pocket screws. Here's another one, contour, pockets for pocket screws, and drills for attachment to the back edge of the tread. Come down here and I can show a stringer. So it cuts the perimeter, cuts the wedged pockets, drills for a screw through for the treads and risers. Then I can go to my treads. So tread cuts the perimeter, cuts a pocket to receive the riser. If this had returns on it, it would cut a pocket for a pocket screw for the return. And that's it. So nice elliptical stair. Every tread is different. I can recalculate this for production. In this case, I'm doing handrails and treads. The skirts and risers are all bent, so we'll laminate those. I'll use a DXF from this to create my forms for all the risers and to laminate the strings. Here's my treads. And each tread is different. But from here, I can go and file, print production drawing, and I'll do it as a PDF. Print. And there it is, so I can just spit that out to the shop floor. They can lay up all their treads from there. And then go back into my software for Staircon and go to create production file. Here again we got wreath rail and treads. I'll just process one tread for this one just so you can see. Then go to one section of wreath here, process that, and out for production. So I mean, literally takes minutes to process the entire G-code for both treads and handrail and send it out to the floor. It's a very large time saver for us. So this particular project is an ellipse. So there's a bunch of changing arcs. You can see the strings are broken here based on the arcs that created the ellipse. What I've done in this particular case is I've joined this rail all the way up through as one piece. And I'll view it on center line. And so what I'll do is I'll view it on center line and then drop it down on top of the stair. And then I'll take my overall length and split these up into equal sections so that each section rail is pretty close to the same length. All right. So here's the top of the stair. The ovaries is the level of the top. You see it's a short changing radius. And this piece here is in the middle of the stair. It's on the left side. It's got a very low pitch line, but and a large arc. And here again, each one of those pieces would take me quite a long time to program if I was going to do it from a 3D model from SolidWorks or Rhino or anything like that. Where in this case, I can just draw it in CAD, process it for production, and off it goes. Now, in the past, when we used to do things with SolidWorks, if the rail were to change or the pitch line were to change, if the floor-to-floor height, any of that would happen, we'd have to remodel that in SolidWorks and then reprogram for AlphaCam. In this case, the floor-to-floor height changes, we change it in CAD, but then process for production, and it's done. It's a huge time saver. You don't have to go through and start all over from scratch. It's a pretty simple edit to make.
We're going to show another project that has multiple levels of floor. As you can see, these treads are all askew, which really makes for a comfortable stair, but the important thing with that is what it does is you take a straight stair that an architect initially had 3 straight runs, then curves, and then straight runs, is the rail doesn't flow smooth and clean. It's very blocky, chopped up. You end up with odd winders. This makes the stair that the path line, walk line, pitch line, everything is very consistent. We'll quickly look to 3D. Here's a 3D stair. We start at a lower level. Wall underneath. We can show the wall, put the wall in, the curves. Here's a stair. In this particular case, the bottom of the stair was all done with the same material, in case it was butternut. Fascias, color-wise, we can transition and change all of these things. Go back to plan views, and we go back and view hide. We can turn the stair off. We just have the floor opening. If you want to be able to send out drawings for F3, we can put dimensions in there, modify the dimensions. We can change the height. We can pull the dimensions away, move them. We have all the controls of what you normally would with any of the CADs.
So here I'm processing this stair for processing the treads, the risers, and the wreath handrail. So this has been processed. We've got treads, got risers, and wreath handrail. So now I'll go and create production file. This will come into CAM. I'm going to open the PRX that I just created. And here I have wreath handrail drilled for balusters. We've got straight handrail here also that we'll also process. Risers. And treads. So again, I'll calculate, process items. Okay, so I've got handrail here, straight rail. Let's get the profile on it. And it's drilled on the pitch for the rail, for the balusters. I can go down to wreath parts. Here again, here's all the tool paths. And again, these are cut and drilled for balusters to cut through the tangent of the rail for tangent handrail method. And these treads are a different profile than what we just showed you. So this is actually an 1 3/4 thick tread. So you're able to run a bunch of different styles of profile, whatever you've got or that you typically do. It's all able to be edited in the configuration for CAM. It also goes with handrail. We run a lot of different styles of handrail. And the profile can be easily added into the database and machined in whatever profile you have and change the settings to work. It can also be changed so you can be plowed out for fillet or drilled for balusters, different size holes, whatever you need to do. It's all very editable and customizable as you need. And also from this point over here in the G-code, it generates the work volume for the part, so you can get your blank size for each wreath section from there and put that out to the shop floor. Back from the CAD side, you can create cut lists, and so you go File and Print Production Drawings. So there's all the scripts for the Mathers job that we processed earlier. You just print this out, get it out to the shop floor so they know what they're making for blanks. And the same goes for treads. Risers are put out a little bit differently. I don't create a production drawing like this because they're simpler. I just give them basically, it prints out a list of risers based on their length and width, and they just rip process from there. The great thing about this is that, like, for this particular stair, every one of these treads is different. So when I would program, before we had Staircon, I'd have to pull each of those treads off by hand and program in AlphaCam. This processing for production is much quicker as far as outputting G-code for these parts.